Alright, we've put all our parts on our schematic here. We've added libraries, changed a few things around, put on our bypass caps. Now let's talk a little bit about how we're going to move our parts from our schematic over to our printed circuit board. So you remember in the beginning, under projects, we opened up a circuit board. And you see this circuit board space is blank. I can zoom in and out with the same functions I did on the schematic. In this case, I just did the shift key down and I rolled my mouse bar. I'm sorry, I do my control key down, roll the mouse bar. It's going to zoom wherever the mouse is centered. If I use space bar, I can scroll back and forth. Right? If I have nothing pressed down, I can scroll up and down. This is all just using my scroll button on my mouse. But let's take a look now. Our PCB is blank. Our schematic's over here, and we want to move those parts onto the schematic. So let's come up to our toolbar where it says Design. And under Design, you'll say Update PCB Document, and there's the name of the document. That's the one we want to update. It's our op-amp PCB. So I'm going to tell it Update PCB Document. And it comes up with a little window here that says Engineering Change Order. And it wants to add these components. It wants to add these nets, component classes, and rooms. Now rooms is something we haven't talked about, but it wants to add a room. I'm going to tell it validate changes. I'm going to look here. I have all green checks. Be aware, sometimes you'll tell it validate changes and you'll get a red X. You can hit execute changes and it will update your PCB and the X will go away and turn to a green check mark. It's always done that. I wish I could answer the question why. I think Altium just is not up to speed with all the changes you've made, and it may not realize that a library is open that you've already opened, so it shows an X. Try it anyway, hit execute changes. Most likely it'll come up green. If it doesn't, then it'll tell you why. Maybe it can't find a footprint. Maybe the library's not open. Maybe you had it open before but closed it. So I'm going to hit execute changes. And I can see here all my little check boxes are still green, so I'm okay. Hit close. And here's my PCB, and here's all the parts. You'll see they're inside this little box, kind of a magenta colored box here. The box is the room, and when I hold my left mouse button down on the room, I can drag the whole room around. If I hold my button down on a part, I can move the part around. So all my parts are in a room, and this room is associated with this schematic sheet. You'll see it says op-amp, and that's the name of our schematic sheet up here, op-amp. If I had more than one schematic sheet going into this project, I would have more than one room, and each room would have the name of it here. Now rooms are not going to be useful for us, so I'll show you a couple things you can do. They'll become useful later, and I can explain why. But right now, I'm going to highlight the room, hit my delete key, and the room goes away. I didn't need it. I can hit save. And let me show you on the schematic side how to stop Altium from generating rooms when you don't need them. I'm going to go to Project, Project Options. There's a tab up here that says Class Generation. I'll click on Class Generation. And right here you'll see it says Generate Rooms. I'm going to unclick that and hit OK. And I'll save it. Now Altium won't generate rooms. If I come up here and tell it Update PCB, it's going to say there's no differences. There's nothing for me to update. There's my PCB. There's my parts. Now let's talk about why you'd want a room. Common things for rooms are you could set rules for a room. You could do several things. One good example is, say, a sound mixer board. If you've ever been to a concert and you see the guy running the soundboard, you'll see that he's got, it looks like a 747 jumbo jet panel there because he's got a bazillion buttons and knobs on there and it looks confusing. But let me explain to you that it's not that confusing. What they have on there is maybe 24 channels. and each channel is set up exactly the same. And maybe channel 1 is going to be the input from the electric guitar. And channel 2 might be the microphone for the guitar player. They can sing it into the microphone. Then channel 3 might go to the bass player. Channel 4, bass player mic. It goes on and on and on. If I wanted to design that project and I wanted 24 channels, I'd have to have 24 sheets, each one with the same circuitry, right? A channel coming in. So let's look. See what we have here. Here's a mixer schematic top level. This is something that we won't get into in these videos, but I'm just going to tell you it's a top level. And here's an input channel. Now this channel would be the plug right here where you plug the microphone in. Here's some buttons for more or less gain. Here's the gain to go to your main system. Here's the gain to go to monitors, right? They can have more than one output. A monitor is a speaker on the stage, so the guitar player and singer can hear himself on the stage. And then this left and right and headphone and effects are going to go out on the board and then eventually out onto the main speakers for you to hear. I would have to have 24 of these sheets. I could do that. I could open 24 sheets. I can copy and paste all these in there. Gets to be a lot of work. When I put it on my PCB, you'll see I'll have to move all those parts individually. But watch what Altium can do. When I had this mixer schematic here, I'm telling it right here on this thing, it says input channel and repeat the channel input 8 times. So I'm telling Altium to do that 8 times. Now here's the PCB for the mixer. You'll see there's nothing on there. That's just a blank PCB. And here it is when they've updated the PCB. Now look what happens. I have channel 1, channel 2, channel 3. This one has 8 channels. I have all 8 channels right here. And what's nice about that is with Altium, I can take one channel. You'll see them placed here. I can take one channel and say, let me take channel 1 here. And I'm going to change the size of the room. I'm going to make the room this big. And maybe I want to move these parts over here. And this thing down here. And I'll move the whole room. And rotate it and stick it here. Now, once I've done that, I can tell Altium to look at this room and make all these rooms look the same. And that's what they've done here. They've taken one room right here. Here's a channel in. It says right here, channel in 1. They've placed all their parts exactly where they wanted them. And they came up and they told Altium, hey, look at this room and make these other 7 rooms look just like this room. The advantage there is I only had to do one, right? I only had to do one schematic, and I told Altium to repeat it. And then I only had to take one room, make it the shape I wanted, place all the parts exactly like I wanted, because I wanted these to all be the same. That way on the mixer board, as I move from channel to channel, the knobs are all in the same position. And I tell it, copy it across, make all those exactly the same. I can then place the rooms on my PCB, route it, and I have a nice project. Anyways, that's the reason for rooms. Like I said, we won't need them here. We have a single sheet and a single PCB. So let's talk about how we're going to set up our PCB. The PCB, this area that's black, is the default size of our circuit board. And you'll notice right down here in the bottom left, I have numbers here that tells me where am I at on my circuit board. And if I look here, the bottom left, I'm basically at X equals an inch and Y equals an inch. I really want that to be my 0 point. So I have some toolbars up here. If I move to this toolbar, utility tools, this little symbol right here says set origin. So I'm going to set my origin. I want this to be 0, 0. So I'm going to control and scroll so I can zoom in, put that right there. You'll see my X and Y currently says 1 inch by 1 inch. I'm going to click it there to set the origin. Now I'm at 0, 0. I'll come up here. This tool still works the same. Fit the document on the page. There's all my parts that I have on my schematic or on my PCB. So I want to place these parts. Let's zoom out a little bit. I can drag with my right mouse button, and I have two B and C's, one input and one output. I don't know which one is which. If I go to my op amp, schematic, highlight this part. See how it puts the green box around it when I highlight it? Go back to my PCB, it's highlighted the part over here. It works for all the parts. Highlight my output, it highlights the output over here. So it's an easy way to identify. The best situation is to have two screens, and I use two screens when I do my work. If you have two monitors, I can put schematic on one monitor, PCB on the other. That makes work a lot easier. Now I'm going to double click my part here, and you'll see that it says, the comment says input, but I can't see it because it's hidden. So I'm going to unhide that. And there's my input. Space bar to rotate. I can lay it over here somewhere. Here's my output. I'm going to double click it and say don't hide my comment. I want to see it. Now you'll see these little white lines on everything. See as I move that around, the little white lines all over the place. Those white lines are the net label, the net connections. That's telling me where I need to connect. That's telling me that this part right here, you can see the white line go all the way up to R101. That's where it needs to connect, and that's where it's going to try to put copper. So I'm going to pay attention to that, because when I place my parts, I want Altium to have the easiest job it can of routing my copper. I don't want all these traces to have copper going on top of each other. So let's place my little op amp here. And then I'll have a resistor. Where does that resistor go? Well, look, it's showing me where it goes. All right, I can place it right here. So I have the shortest route. If it was rotated, I can see the copper would have to cross each other. So I'm going to rotate it this way. Let's see, here's another resistor. That one might be easier this way than doing like this. I can lay it here. Some of these parts will move around. Now I have some capacitors. You'll see that my bypass caps are C102 and 103. I can highlight that part to make it easy to find. Here's the 102. And remember what I said about bypass caps. You want those caps to be as close to the power pins as possible. This yellow that I'm moving around is the silk screen, the top overlay that's going to be on top of a normally produced board. You've seen the normal circuit boards are usually green, and they'll have a white overlay, a white silk screen that has this information written on it. I'm just moving that around so it's readable. So let's see, here's more cap. Here's 103. That one is going to go down here. Right, I could stick it way over here. Not a good idea. That's my bypass cap. I want it close to the pins. There we go. Now, this was my power input. I can stick it up here somewhere, and I'll have some bypass caps for my power input. Now, placing and moving these parts was just like placing the parts on the schematic. I'll place one of those, and now this one I know is also a bypass cap. I can place this one. I might want to slide that one over, make room for this one. These are the electrolytics we placed. Now look, that text, I can't read it right. I have text on top of text. So I'll just move it. Here's another one. I can zoom in a little, it's easier to see. Now, I don't want to put it this way. If I do, look at my net lines, they're trying to cross. So I'll rotate it, move my text, place my part. Now, watch what happens if I place my parts and I get them too close to each other. Do you see the parts turn green? Green is warning me that they're too close together. There's a rule violation. It could be any rule. I don't know what it is. Let me right click on that part. I have a thing that says violations. It's telling me component clearance constraint. There's a collision. I'm closer than 10 mils between these two parts. So it's warning me I'm breaking a rule. Let's move that back. Oh, the green goes away. I'm not breaking any more rules. We'll talk about rules too. Now here's my R102. R102 was our output resistor, right? I can highlight it there. So there's our R102. Now, do I need this way over here? No. I can make that closer. So we kind of have a rough basic layout here. We'll talk a little bit about our placements and changing the board shapes and moving parts. If I wanted to move all of these parts together, I can draw a box around these parts and move them all at once, just like we did on the schematic. So most of this stuff works the same way as it did on the schematic. Let me move this up here and I can slide this down. All right, I can tighten this up a little bit. I want to make it a little smaller. A little bit smaller is nice because when you make printed circuit boards, you pay by the square inch. So my story I always like to tell everybody is if I'm going to make 1,000,000 of these and sell them, and I can make my PCB a little bit smaller and use maybe one cheaper part and save 50 cents, well, 50 cents over 1,000,000 boards is $500,000. And then I like to smile and laugh and say that $500,000 is buying me a house in Bermuda. So think about it. You want to make this thing as efficient as possible without making your life too hard that you won't be able to put your parts in or work on them. All right, I'll move this down a little bit. Let's see, I can probably move this resistors a little bit closer. Don't go too close, they'll turn green, right? Green's warning me I'm too close. All right, so there's a kind of a rough shape for a layout. But look, I have a giant board and all my parts in the bottom left. How do I change that? How can I change the shape of my board? Well, let's change it because it's very, very, very easy. Under the bottom here, you'll see I have tabs. Top layer, bottom layer, top overlay. That top overlay you see is yellow, just like the box. The top overlay is the silk screen. I want to click on this one that says keep out layer. The keep out layer is what we're going to use to define the board shape. So I'm going to click keep out layer, come up here to place, because I'm going to place a keep out layer. Don't make the mistake of coming down here and saying keep out. It won't work. I don't understand why it doesn't work. It says keep out, but it has something to do with how the layers are defined and how our board production equipment here on campus works. If I select that, it won't be able to find the board outline. So I'm going to go to keep outs, place, and I'm going to click line. I want to place the line. So now I'm ready to place a line. For better accuracy, I zoom in. I left click to start placing my line. You'll see that line is the same color as the tab. I can zoom back out now because it's much faster to do this. And I know I need to go about this high on my y-axis. Let's see. How about 1.65? So I'll come up here to, you'll see when I hold this here, I can look at the bottom left. And I see where my X and my Y is. And my Y tells me I'm at 1.65. So I'm going to tell it that's how high I want to go. I'll zoom in again. And I'll start looking at my Y coordinates until I get to 1.65. There it is. I'm at 1.65. My X is at 0. I left click. Now you'll see as I go across, this thing will scroll, but it's easier to zoom out. I can look here and say, where do I want my X to go to? How about 3.9? That looks good, 3.9. So I'm going to come up here, zoom in, and say 3.9. My mouse is right on it by luck. I might have been up here or over there or out here, but I'll come in here, 3.9, 1.65, and I'll click. Now if I start going down, it will go down. It just takes a while, so I'll zoom out, come down to my 0 line, click. Now I've set that one, but let me show you that you can make board shapes any way you want. I might need a notch in my board. I can click here, I can come up, draw this notch, I'll zoom out, I'll zoom back to my origin, click, and then I'm going to right click to say I'm done placing those. Let's show the entire document. So now I have a board shape here, a keep out that I want to use as a board shape. You see my board's still defined way out here. So click on one of those lines to highlight it. You see that's highlighted now. Hit your tab key. This is a great keyboard shortcut. If I hit the tab key, you'll see they're all highlighted now. That's much faster than trying to hold the shift key down and find all those lines and click on them. Now come up to Design, Board Shape, and it says Define from Selected Objects. And what do I have selected? My keepouts. So I'm telling it I want my board shape to be defined from my keepouts. Let's hit click. There's my board shape. Now I've changed my board shape to fit those keepouts. I'll zoom to fit. Very good. All right, so I got my board shape in there. It's all good. I'm going to stop here now and we'll come back in a little bit and we'll talk about rules and routing copper.